Hey guys, welcome back. So in this video, we are going to be producing a windmill with a slightly strangely spinning set of blades like this. We will update the actual windmill model so that the blades are separate, and then we're going to write a spin me script that you're welcome to use on any game object that you want to rotate, that you can set RPM on and give it a couple of axes of rotation to make this slightly weird, purposefully slightly weird rotation. So let's dive in and see how that's done. Okay guys, so welcome back. What we're going to be doing here then is starting by talking about the implications of importing new assets into a scene that already has assets in them. So for most of the objects in Rick's environment, if we just flick through them while focusing on the transform over in the inspector there, you'll see that nearly all of them have a scale of 1, 1, 1. They are unscaled objects, right? Now that's quite important because let's look at the windmill. It has some scaling applied to it. Well, you'd think, so what? The problem with that is we can't instantly update that model without causing a scaling issue. Let me show you. I've provided you with this video a pack that will allow you to use the windmill. So it's called windmill.unity package. So if I bring windmill.unity package into your project, into my project, and you can go and get that and do that for yourself. Firstly, I want to tell you something about the way these packages import. If you're taking a package that you don't understand or that you've not seen before, you want to look at this very carefully before you click the word import. Because it is going to use absolute path names and it's going to overwrite any assets you have in the file system where it's showing you on the screen. And it's telling me actually it's going to add a new handful of materials and it's going to add a new spinme.cs script in the utility folder, whether I like it or not. And then it's also going to update a few things. It's going to update, which are these little black arrows, a few other materials. Okay, now I'm going to let this happen in this case. I'm going to update the windmill. Why? Just before I do, I'll show you why. If we look at the current windmill in the scene, which is an older version of the art asset, it is a single mesh. And because it's a single mesh, I haven't got a snowball's chance in hell of rotating this windmill by script because it is all a single mesh. All right. So the idea is that we split that out and maybe made some other improvements to the windmill. Doesn't matter where in your assets you drag that Unity package. When I import, it comes in, it overwrites everything. Now watch what happens to this windmill. It's not going to look pretty. Boom. Not so clever. Now that's because of that the scaling. So it's okay. In this instance, we noticed it and we can just scale back to 1, 1, 1 and we're all good. But imagine there were lots of windmills all over the massive scene. If they had scaling, they would have taken on that scaling and ended up distorted, which isn't ideal. All right, so that's why we keep our top level objects with a scale of 1, 1, 1, tending to put our colliders on there, any scripts on there, and then we have sub objects holding all the meshes as needed. Cool. So that's the first part of the video. So now what we're going to do is we're going to talk about bringing objects to life with script-based rotation. Now, for any exciting animation of these sails, which by the way are now separate objects, if I now go to the blades, sub-object of the windmill and do a rotation in Z, look, the windmill spins because it's able to do that, provided the pivot point, which is something you'll have to talk to your artist about, is in the correct place, which it is in this case. If you're going to animate this guy, obviously normally you just use the animator, right? But in some instances, it's easier just to use a script to animate this. And you may want to also script some behavior. So there's two options to moving things. Just be very clear on what's moving it, whether it's a script or whether it is the animator. In this case, we're going to use a script. All right. So I'm going to talk to you a little bit about how we go about writing this script and about a useful tool based on something called dimensional analysis. Now that sounds complicated. I've linked you it in your resources. Here's the Wikipedia page on it. It's not actually dimensional analysis we're doing. The idea of dimensional analysis is that in a physics formula, you must have the same units on both the left-hand side and the right-hand side. You've got to compare apples to apples, meters to meters, meters per second to meters per second, etc. All right, we're not really talking about dimensions or SI base units here. We're just talking about units because we're going to be talking about things like degrees per second when this thing spins. And degrees, strictly speaking, is a dimensionless quantity, but it does have a unit. It's called a degree, but it doesn't have a dimension. So don't worry about the very details of dimensions versus units versus SI units. That doesn't matter. What I want to show you when we get into this utility script, which you'll find in the utility folder called SpinMe, is I just want to show you an approach to use unit consistency of units to help you code. Okay, so what I'm going to want you to do is actually write some code and finish this class off. But firstly, let me introduce you to the class. We have 3 exposed variables using serialized fields so that they're not settable by other classes, and X, Y, and Z rotations per minute, defaulting to 1 rotation per minute, very slow. this spinme.cs is attached to the windmill blades, and the idea is that when the script is finished writing, it will rotate at 5 RPM in the z-axis, which is the normal kind of windmill rotation axis like this, but it will also have a little bit of x rotation or y rotation, which will serve to make the thing wobble and look a bit strange, which is good fun. Now, how does this work? So we ultimately want to set the parameters in something very human, readable, rotations per minute. Our designer can come in here and very clearly go, yeah, 5 rotations per minute, RPM, I know what this is. So that is a constraint we're putting on ourselves as programmers. We're saying that we want to put in RPM. All right. Then when it comes to, let's look at the other side of it, when we actually rotate around these 3 axes, transform.right, up, and forward, which is the way that you get the local relative direction rather than the global direction. So we use right, up, and forward corresponding to x, y, and z. Why right, up, and forward? Look at the gizmo thingy here. Remember that right is a bit confusing because it's actually the opposite. Right and left sometimes you'll have to experiment with, but up and forward are quite obvious. Up is y, and forward is the z. And then actually, when you look at it like that, up is y, forward is z, and x is right. So that all ties together in terms of the handedness of the coordinate system very nicely. All right, so on the output, we're going to every frame say translate.rotate around the position of the thing. Well, the root of the blades is in the right place. The pivot point is in the right place at the base, at the pivot of the rotation. That is the position we rotate around. This is the axis we rotate around. And then we're going to want to rotate a certain number of degrees per frame. Well, that's constrained as well, because at the end of the day, that is what this method wants, right? It wants us to tell it the angle it's going to rotate. And of course, because we're inside the update loop, it is the angle that we're going to rotate in this frame. So we know that we need x degrees per frame coming out, and we have decided that we want x rotations per minute coming in. Therefore, our challenge is to write a formula here that is not 0 degrees per frame, because that's a very, very boring spin script, but it's to write a formula that gets the correct number of degrees per frame. So this is what you're going to need to do in the challenge that's coming up for you in a minute. Okay, but before we do that, let me equip you with the idea of using something similar to dimensional analysis, but much simpler to do this. Dimensional analysis, if you want to read about it, is linked in your lecture slides and is here on Wikipedia. And it talks about the fact that the left and the right-hand side of physical equations must have the same units on them. You need to compare apples to apples or meters to meters, oranges to oranges. You get the idea. I'm not doing dimensional analysis. I'm just making sure that the units of the thing on the left and right are equal. Degrees, minutes, etc. They all need to balance out. So let's start just using comments here, right? And just put some stuff down. We know that if we want this to work at a consistent speed, regardless of the game's current frame rate, what comes to mind right now? I'm saying this needs to be frame rate independent. You should be thinking at this stage in your Unity of a method called time.delta time, right? So we know that on the left-hand side, we want x degrees per frame concretely. We know that on the right, we're going to have time.delta time. Doesn't matter if you spell it right here, because this is just sketching. We know that it's time.delta time. I'm going to say comma, because I don't know whether to multiply or divide. This is part of it. I know that I'm going to be using something like 60, because there are 60 seconds in a minute. And we're talking about seconds in time.delta time, and we're talking about minutes up in the parameter that comes in, okay? So we know we have a 60. We know we need a 360 because there are 360 degrees in a rotation, and we're using the word rotation up here. So somehow I have to tie rotation to degrees. And what else do we know we need? We also know that we're going to need this rotations per minute. So they're the constituent things, right, that we're going to be using just as a comment. Now, let's look at it from another angle. Let's look at it from the angle of what are the units? What is degrees per frame? Well, I'm going to write it like this. Degrees, space, frame, shift 6 for the caret -1. That is degrees, and then raising frame to the power of -1, which is the same as saying degrees over frame. But if we start using overs in this, it's going to get really confusing, because the moment you've done a divide and then I've got something else. Now, what do I mean here? If I say times something else, it's, oops, hang on, I'm in non-insert mode. If I now say times something else, suddenly got really confusing, right? Do I mean degrees per frame times something else, in which case the something else is on the top of the equation, or do I mean degrees divided by frames times something else, in which case something else suddenly is on the bottom of the equation. Very ambiguous, not very nice. The whole point of this technique I'm showing you is to avoid that ambiguity. So write degrees, frame to the -1, keep it all on the top of the equation. Okay, time.delta time. We know that this is in seconds per frame. Now, frame isn't actually a unit or a dimension as far as physics is concerned. Frame is just a concept. It doesn't have any units or dimensions. But we're trying to match words to units and dimensions and numbers here. And this process works. So time.delta time is in seconds per frame. Now, I'm going to use a comma again because I don't yet know whether the 60 should be on the top or the bottom. But what is 60? 60 is seconds per minute. So minute to the -1. All right? Now, I want you to finish this. This is the challenge. I want you to finish spin me using this same idea. If it works, the windmill blades rotate at 1 RPM and use dimensional checking to help you. To finalize that, to give you the last piece, what you're going to need to do when you've put these other two things in with commas is change them to either timeses or divides, depending on whether you ultimately want these things to stay on the top, to be cancelled out or not. So if we times seconds per minute by seconds per frame, what do we get? What do I get if I times seconds per minute by seconds per frame? Let me just put that on another line. Just to make sure that you understand this, if we try and do seconds per frame times seconds per minute, what we get is seconds squared, which we don't want. And then we get frame to the -1 because it's still on the top. And because we multiplied, we end up with minute to the -1 on the top as well. I've put in some extra spaces. Not what we want. How about if we did seconds per frame divided by seconds per minute? Well, what happens now is that the seconds disappear because that divides away from that. And now you have frame to the -1 and then minute not to the -1 because dividing by something to the -1 puts it back on the top. Okay, so that's the type of simple algebra that we need, that is worth considering being able to do in comments. Now, you could do it on a piece of paper. I could show you that on a piece of paper, standard maths and cancelling and dividing through, very much, in fact, like the Wikipedia article will be showing you here with cancelling these. This is exactly what we're doing. But I'm just doing it in comments because it's where we're coding, it's where we're living, all right? So I'm starting with this, comma. I'm going to use commas to start with and turn them into divides or timeses depending on how we want things to cancel out. And I want you to have a go without hacking at it. What you'll often find that you do with this sort of thing is you just hack at it until it works. Well, this will allow you to do it a little bit more formally. If the formulas get too big, you'll spend forever trying to find the right permutations of things to get the right answer. Use a system like this, much, much easier. And of course, test it at the end and make sure that it works. So go ahead, pause the video, see if you can write that and get this thing rotating in X. It'll be really weird in the X axis. And if you want, go ahead and do it for Y and Z at the same time. I'll be back in a minute. Okay, welcome back. So I'm just going to update the bottom of the video so that we know we are doing the challenge. We have also already talked about why we keep root objects at the scale of 111. We talked about that with the windmill. So let me show you the challenge solution. So we have seconds per minute. Then we have 360 degrees per rotation. Use exactly the same words as you used in all your variable names. Degrees per rotation. And the final thing we have is rotations per minute. Okay. We're nearly there. Now what we need to do is say, okay, what does this mean we need in terms of multiplies and divides? Well, we want to end up with no minutes on the left-hand side. So our minutes have got to disappear somewhere. And also we need to cancel out this seconds with this second. So I'm going to go for a divide here. That means that we're just looking at what I've highlighted. The seconds has disappeared and we have frames to the -1 times minute. So we're good. We've got the frames to the -1. We've got an extra pesky minute hanging around. How are we going to get rid of that minute? Well, we can multiply by rotation per minute over here. And then we're doing nicely. Let's break this down one thing at a time. So what we've currently got is degrees per frame equals. I've done this. Seconds per frame over seconds to the minute to the -1. What is that? Well, it's just frame to the -1 minute. Okay? That's what we've got so far from these two. If I then multiply that by degrees per rotation and multiply by rotation per minute, let's do one more line of working so you can see all the maths working. What happens? Well, the rotations cancel here. and the minutes cancel here and here, and we end up with frames to the -1 times degrees, which is the same as degrees per frame. We're good. So we know that this is divide, this is multiply, and that's multiply. Because we already kind of wrote it out at the top, we're pretty much home free. We have time.delta time, which is a property of the time class, divided by 60 times 360. Now these are magic numbers right in our code here. Arguably you don't use any number larger than 2 in your code. We could parameterize these, but I'm not planning on changing the number of seconds per minute or the number of degrees in a circle anytime soon. I neither have the authority nor the ability to do that, so I'm going to leave these because they are pretty hard-coded into the way that we work on this planet. All right, and then the final thing is this x rotations per minute. We multiply up by that, and we should be good. I'm going to leave the working there and make sure that with a setting of 1 in the x rotation, that we actually do end up with the windmill doing something really squiffy and strange once per minute. And it's going to be hard to tell with once per minute, but it's going to be very easy to tell with once per second. So let's just try it at once per minute. What does it do? Who knows? But if we go to 60, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. It looks a bit fast to me. 6, 7, 8, 9. No, I think it's about right. All right, that's cool. So now all I do is, of course, apply exactly the same formula with a tiny transposition of the this x to a y to the other 2 lines. Hang on. Oh, mishandling the keyboard here altogether. Let's try that once more. We pop that in there. Change that to y. Pop that in there. Change it to Z, and I think we're going to be home free. Let's go ahead and try it in the game. Play the game. What have I done wrong? Something silly. I have left in a semicolon and a 0. Let's have a look at the windmill. Hopefully it will have its desired effect of looking, there you go, there it is, it's spinning. It's spinning mainly around X, but I've put enough Y rotation in here to make it just look off. And that's the idea, is the player just sees it as that's weird, and that fits in with the design of our game. So that's it. We've done it. Congratulations on getting this far, and I will see you in the next video.